Hello, everybody, and welcome to our next talk, Deciphering Color and Accessibility through our Leonardo tool. I'm Nate Baldwin. I'm a senior designer on the Spectrum team. My background is in fine art and illustration, and I'm a self-taught web developer. But my focus on the team is systemizing design decisions, finding different ways to automate, simplify, refine, or scale design processes. One of the outcomes of this work has been the creation of our tool, Leonardo. So today what I'm going to talk about is a little bit of the problem that we have with creating accessible colors, then the constraint-based color scales for Leonardo, as well as Leonardo's method of generating colors by contrast ratio. I'll talk a little bit about Leonardo's API, and then we'll go into Spectrum's adaptive color theme and Spectrum's colorblind safe colors. Color is a very powerful tool. Color communicates ideas and emotions. It's how we recognize and interpret things in the world around us, such as the ripeness of a banana. Color is a foundational aspect of visual communication. We use it for things like stoplights. And in user interfaces, color is used to express brand, draw attention to important elements, and reinforce semantics, such as validation errors. But not all people see color the same. Some people have visual impairments, color vision deficiencies, or situational and environmental variables that affect the way that they see color on a screen. For many people, this results in difficulty distinguishing a color from the background, in particular regarding the legibility and readability of text, or the identification of user interface components. The Web Content Accessibility Guidelines, or WCAG, provide guidelines and criteria for meeting the contrast accessibility of colors. These standard guidelines are foundational elements to every design system's color palette. It's a shared solution for the consumers of digital experiences, and both a solution and a problem for the designers who create them. So why is this a problem for designers? Well, it comes down to the actual properties of color and the mechanisms available for us to adjust colors in order to meet contrast requirements. Now let's take a look at color properties. Digital colors are defined in RGB. They're a combination of light signals from red, green, and blue channels from a digital display. This is modeled after the human visual system, which has sensitivities to 3 distinct wavelengths of light, known as trichromatic vision or trichromacy. The idea here is that with just 3 colors, you could represent every possible perceivable color. These RGB channels, or the RGB color space, takes the 3-dimensional shape of a cube. However, these channels are modeled after the physiology of the eye, and they don't really account for the way that humans think about color. With a little geometry, alternative models are available that conform more closely to how we think about color. Things like hue, saturation, and brightness, or hue, saturation, and lightness. While none of these account for the perception of color, these cylindrical models are a little more easy for humans to reason about, and the channels are named relative to common concepts or properties of color. These models are familiar to how designers pick colors, and for any given color that is picked, adjustments to these properties may be needed in order to meet contrast minimums. Changes to brightness or saturation can affect the contrast of a color. In this case, we have a new version of a color that meets a 3:1 contrast minimum for large text and UI components. Further changes may be necessary in order to get a higher change in the color's contrast. In this case, we need a version of the color that meets a 4.5:1 contrast for small text. However, sometimes changes to these properties, while they can give us an appropriate contrast, their appearance doesn't really look that good. In these cases, a change to hue may provide a nicer looking color. However, even when changing hue, contrast can be greatly affected. So with another change to saturation, we can resolve this color to one that looks good and also meets the 4.5:1 contrast. Now, when working with HSL and HSV, any changes to hue can have dramatic impacts on the contrast. In this case, a blue that was 4.5:1 When the hue is changed to yellow, it's suddenly 14.8 to 1 contrast. So let's go back to our blue. So 3 of the different values that we picked in this process could be the beginning of a UI color system. When picking a small set of colors like this, the manual adjustments to properties in order to meet contrast ratios isn't that much effort and isn't too big of a deal. However, when you have multiple tints and shades and several different colors in your palette, this can become daunting. In fact, the changes that you make to one color's hue and saturation won't work for any other color. Nothing is reusable or scalable in this approach. For our team, we recognized right away that this is something we needed to have a systematic framework to help us solve. Spectrum's color palette consists of 13 different hues. Each of these hues are used in 3 different color themes. In other words, the contrast for these colors must be evaluated against 3 unique background colors. Now, when you factor gray into the equation here, the challenge that we now face is that there are 40 instances of a color needing to meet a 3 to 1 contrast and 40 instances needing to meet 4.5. Now, this illustrates that the rate in which small problems can scale when working on a UI color system, especially when you have multiple themes and multiple colors. This problem is one of the core drivers behind our team's creation of Leonardo. Leonardo is a tool for creating accessible color palettes with a focus on systems in order to ensure colors can scale for multiple themes and can be more easily created, maintained, and changed over time. Now let's look at this color again, but this time from scratch. All right, we know that we may need to darken it or lighten it, depending on the contrast ratio that we're trying to meet and the background color that it's going to be compared against. We start this by defining the known absolutes. Okay, the darkest dark of this blue is going to be black, and the lightest light is going to be white. This helps us to create a full range of possible color values that we could use to meet any particular contrast ratio. These constraints in Leonardo give us what were called color scales, and they're the beginning of a system for color constraints defined by designers. Let's dive into that a little bit more. What do I mean by color constraints? Well, much like the problem we faced earlier, designers may want to modify the hue or saturation of a color as it gets lighter or darker. To do this, we've created the concept of key colors. Key colors are similar to keyframes in animation. They are snapshots of a color defined by the designers and used by the system as markers on a path through 3-dimensional space. Here we can see the path that our color scale takes in the HSV color model from white to blue and then to black. In order to modify this color scale, we can specify additional key colors in order to provide the information regarding hue and saturation shift for our tints and shades. And what this means is, rather than defining every individual tint and shade of a color, you can specify only a small set of key colors, and Leonardo will fill in the rest. Now you may notice that the path that this color scale takes in the HSV cylinder is irregular and a bit of an unusual shape. When creating color scales or even gradients, designers put a lot of attention on making sure the changes in hue and saturation along their color scale appear as natural as possible, or in some ways, perceptually uniform. For this, Leonardo offers another solution. Let's look again at that HSV color model. Now, this model is good for representing the way that we think about color, but it's a very poor representation of how humans actually perceive color. Now, if we are to take these colors and reposition them on the y-axis based on their unique lightnesses, then we start to see a better representation of each color. Yellow is lighter than blue, blue is darker than red, etc. Next, we can reposition the hues based on their relative proximity to one another. For example, lime green is very similar to yellow, so those hues should be closer in proximity. This gets us towards color spaces that are based more on human perception of color. And these color spaces are called uniform color spaces, and they don't take on any specific geometric shape. They're close approximations to the way that we see color and are an important component of Leonardo. These models provide us for ways to create and evaluate color scales that are based on the science of visual perception, effectively giving us a mechanism for quantifiably evaluating how natural, balanced, or uniform our colors appear. Leonardo includes these color spaces and many more in order to offer designers as many options as possible for the interpolation and sometimes evaluation of their colors. Each color space has its own benefit, which can also depend on the individual who's creating the colors, what they're trying to accomplish, and how they want to evaluate it. However, some of the core functions and foundations of Leonardo are built specifically using uniform color spaces in order to help maintain that perceptual balance where it's appropriate. Let's go back to our blue color scale. In Leonardo, we can evaluate the color scale's rate of change in hue and saturation in a perceptually uniform color space. Now, this shape is a little less irregular. What this does is it eliminates any unusual or inexplicable irregularities that you would see in any other color space. Another way to think of this is a smooth appearance to a gradient will closely correlate to a smooth graph in a uniform color space. So these colors, the color scales, provide us with rules for the aesthetic of a color at any given lightness. This takes out the color properties out of the equation entirely. Now all we have to concern ourselves at this point is with contrast. Contrast is a comparison of two colors. With Leonardo's color scales, we have a range of colors that can be leveraged for finding values that meet specific contrast ratios. Whether that means darkening the color along the color scale, or if that means lightening the color along the color scale. The scale provides a predictable way to identify colors that meet our desired contrast ratio while remaining on brand. However, if we change the background color that the value is being compared against, the selected color may no longer meet our desired contrast ratio. Since Spectrum has multiple color themes, we wanted an approach to this problem that could scale more easily than just picking colors along a scale. The solution that we came up with for Leonardo was to think of this more like a math formula, where the color scale is just a variable in the equation. Now let's see what this looks like. To begin with, we know what our color scale looks like, and we have all the specifications for how that color should appear at any given lightness. Next, we have three background colors. For Spectrum, this is our light theme, dark theme, and darkest theme. The next variable is the target contrast ratio. And what we're trying to say here is that we would like to find specific colors along this scale that meet a 4.5 to 1 contrast ratio for each of our background colors. Leonardo uses an enhanced binary search to find a matching color for each of these color themes. This approach enables us to find the closest matching color that either meets or exceeds the target contrast ratio for each theme. What Leonardo then gives us is unique colors that meet specific target contrast ratios within the design constraints defined for each color. This operation is what made Leonardo the first of its kind contrast ratio-based color generator in the design systems tooling space. No other color tool could offer this level of systemization and precision. So how does this all work? Well, Leonardo was built first as a JavaScript tool. The core functions were built into a flexible API for color generation, and an interface was built on top of all of that. In order to create a new scale, we need to create a new class instance of a color. These color classes take arguments for the color's name, the key colors that you've specified for the color, and the color space that you wish to use as an interpolator. There's also a Boolean option for smoothing, which applies a Catmull-Rom curve to the interpolation path, which can enhance the appearance of your color scale. Along with these, each color accepts a list of target contrast ratios, that you may want for the output color. A new class instance is then created for each color scale in your system, and then those are passed to a new class instance of a theme. This theme will take each color scale and create the output colors based on the context of a background color. The recommended way of specifying background colors in Leonardo is to choose one of your color scales, in this case gray, and pass it as the background color. A related parameter for lightness will determine the actual color of the background. In this case, a lightness value of 100 would equate to white. The contrast and saturation parameters affect the theme as a whole and can be used to universally increase or decrease the contrast or saturation. The new generated colors can then be output as a JSON object or as key value pairs. Since the theme is a class instance, setters can be used to modify the theme after it's been instantiated, enabling you to update color values for light and dark themes, low and high contrast themes, or custom themes altogether. Demonstrating the API for Leonardo helps to illustrate the simplicity and scalability that Leonardo offers. Once colors are defined, themes can adapt by lightness, contrast, or saturation independently. And this is nothing like anything else available, and provides Spectrum with a much faster approach to color systems authoring. On top of that, it provides us opportunities for future inclusive design. And this brings me to Spectrum's adaptive theme. Spectrum has used Leonardo as the backbone for creating a fully adaptive color theme. This means that any possible lightness of a color theme can be generated automatically. In fact, the inputs to change lightness, contrast, or saturation could even someday surface in Adobe applications to provide our users with a more robust personalization of colors, while still being able to maintain a relative relationship with the WCAG contrast requirements. In other words, we could meet WCAG contrast minimums and allow users to increase or decrease contrast to meet their specific unique needs. And beyond theming, Leonardo provides our team with tools to assist in choosing colorblind safe colors. We can pass a list of all existing colors defined by Spectrum's theme, specify a degree of color difference that we want, whether or not we want those colors to be 3:1 with the background, and select all various color vision deficiencies that we'd like to support, and Leonardo will cycle through all of our colors and provide a list of colorblind safe colors that meet our specified constraints. We can then choose and refine a selection of these colors to be used as a colorblind safe palette. This aspect of Leonardo goes above and beyond anything else available in color tools today. Once again, we can use a systems-oriented, constraint-based approach for making a design process that could take weeks or even months to accomplish into something that can be completed in a single day. So I've talked about the complex problem around color and accessibility. Leonardo has helped our team to solve this problem with the use of constraint-based color scales and the generation of colors based on target contrast ratios. Leonardo is used as a springboard for our team to implement a more inclusive and fully adaptive color theme that could one day provide personalization options for our users. And Leonardo also supercharges our capabilities as designers to create a colorblind safe color palette using existing theme colors. These are some of the primary ways in which Leonardo has become instrumental in Spectrum's creation of an accessible color system. Thank you.